Today's lesson will involve word problems involving rational equations. We'll review the mixture and work problems and learn about distance problems. So in this mixture problem, it says that Mia adds a 70% acid solution to 12 milliliters of a solution that is 15% acid. So I know I've got 12 milliliters of something that's 15% acid. I'm changing that to a decimal. And what am I adding to it? I'm adding a 70% solution. And I don't know how much I have. So I'm going to say let that be X. I want that to be 70%. So together I have 12 and X. So I have 12 plus X. And I want that to be 60% acid. And then I've created an equation. I can just do my multiplication. I've got 12 times 0.15, which is 1.8 plus 0.7x equals, here I'm going to distribute. I'm going to take 12 times 0.6, which is 7.2. Plus 0.6x. I'm going to subtract 0.6x from both sides, which is 0.1x. I'm going to subtract 1.8 from both sides, which is 5.4. And then I'm going to divide by 0.1, which is going to give me x to be 54. So I would need to add 54 milliliters of a 70% solution to create a mixture that is 60%. In this problem, we're adding a 65% fruit juice to 15 milliliters of a drink. That's 10% fruit juice. So this is what I'm starting with, 15 milliliters of 10%. What am I adding to it? I'm adding a 65% juice solution, and I don't know how much of that. Together, again, I'm going to have 15 plus X milliliters, and I want it to be a 35% solution. Again, I can just do my multiplication. 15 times 0.1 will be 1.5 plus 0.65X equals, distribute this, 15 times 0.35 would be 5.25. Plus 0.35x. I'm going to subtract 0.35x from both sides, which is 0.30x. I'm going to subtract 1.5 from both sides, which is 3.75. And then doing my division, dividing both sides by 0.3. Gives me, bear with me here a second, which gives me 12.5, and that would be milliliters of that 65% solution. Work problems. To remember, in our work problems, we talked about a couple techniques, one of them being together over alone, plus together over alone equals 1. And then the other method talked about what can be done each hour. In this case, as every year, the junior and senior classes at SHS build a house for the community. It takes the senior class 24 days to complete that house and 18 days if they work with the junior class. How long will it take the junior class to complete a house working alone? So that's what we're looking for, is the junior class's alone time. The 24 days, or the 18 days, is our together time. And the senior class's alone time was 24. So setting this equation up, I'd have 18 over 24 plus 18 over x, and that's going to equal 1, which is the amount, the number of jobs I'm doing. I'm doing one complete full job. Solving this rational equation, I'm going to multiply by its common denominator, which is 24x, and that would give me 18x. Here the x's cancel, and 24 times 18 is 432. Equals 24x. I'd subtract 18x from both sides. I've got 6x equals 432. And 432 divided by 6 is 72. So it would take the junior class 72 days to complete it by themselves. Next problem, it took Anthony and Travis 6 hours to rake the leaves together last year. The previous year it took Travis 10 hours to do it alone. How long will it take Anthony if he rakes them by himself this year? So again, our together time is 6. We've got Travis's alone time to be 10. We want to know Anthony's alone time is our variable. So I'd have 6 over 10 plus 6 over x equals 1. I'm going to multiply everything by 10x. Here the 10's cancel, I get 6x. Here my x's cancel, I get 60. Equals 10x. I'd subtract that 6x from both sides. And x would equal 15. The other method, just to show you this, if you think about how much of the job would they do in 1 hour? And so Travis could do 1/10 of the job in 1 hour. Anthony, since we don't know their time, would be 1 over x. And together, since they do it in 6 hours, they could do 1/6 of it in 1 hour. And then we do the same thing. We'd multiply by our common denominator, which would be, in this case, 30x. Here I'd end up with 3x plus 30 equals 5x. I could subtract 3x, and I get x to be 15. So either method's fine. Either method works perfectly.